Hello and welcome. This is the course on financial management MBA ZG 521 and my name is Krishnamurthy Bindumadhavan. We are discussing risk management and we have been discussing so far how to calculate the returns, the simple returns, and then how to calculate the average. And we discussed about the arithmetic average or the arithmetic mean and the geometric mean, right? This is what we have done so far. Now we are going to define risk and how to quantify or how to calculate a measure of risk. That's what we are going to do in this segment. So this is part 2 of this particular segment, right? And we have another part 3 as well. So let us first define risk. As I have said earlier, if you look at the stock market, what do you see? You will see that the market is choppy. It goes up and down, something like that. Let's actually go and take a look. So if you go to the NSE website, so you can see here the market is come down, then it has gone up and it's continuing to go up and so on, right? You can see that, right? This is only within today. This is intraday. You can get this for the last 1 month and you will see similar kind of a trend. It will go up, it will come down, something like that. So that's what happens to the market. Markets are constantly moving, and moving means it may go up, it may come down. Coming back to our slide. So we define risk as the variability of returns from those that are expected. Variability of returns from those that are expected, which means the unexpected variability in the returns is what is defined as risk. That is the definition of risk. So how do we quantify that, right? I have given a few questions for you to ponder on over here, and you can think about those. I'm not going to focus much on those. You can think about those. But the key point is that the risk is defined as the variability of returns from those that are expected. Our question then is, okay, we have defined that. So in other words, what we are saying is we see a lot of variability. And if there is variability other than what is expected, then quantification of that is a measure of risk. So how do we quantify that? The way we determine the way we capture that is through the standard deviation. So before we get to the standard deviation, let us define the expected return. This is nothing but the average, but then depending on whether it is a discrete or a continuous distribution, the calculations are slightly different. So we are going to look at how to calculate the expected return, which is nothing but the average in the case of a discrete distribution. In the case of a discrete distribution, what we do is we will have is a set of probabilities. Okay, we will have a set of probabilities and we will have a set of returns. So we will have a probability and a return, probability and return, probability and return, and so on. So we are going to take this probability and multiply it with the return, or take the return and multiply it with the probability, and then we will add it. We will add all of those together, and that will give us our average or expected return. So in other words, the expected return in the case of a discrete distribution, the expected return is nothing but the product of the probability with the return for a particular instance, that is the ith possibility. So if Ri is the return for the ith possibility, and if Pi is the probability of that return occurring, and if n is the total number of possible combinations, then what we do is we take the Ri, multiply it with Pi, and we do it for first, second, third, and whatever, how many ever we have, and then we add all of those up. So after multiplying, the product we find out, and then we add up all of those, and then the answer that we get, that is our expected return. So that is how we calculate it in the case of a discrete distribution, right? So this we have defined previously and we have seen. So that is nothing but our arithmetic average we are talking about. But the arithmetic average is a definition, but we have to modify that in the case of a discrete distribution, and this is how it turns out to be. That is, we will have probabilities and we will multiply those probabilities. If it is a continuous distribution, whatever the calculation we did earlier is valid if it is a continuous distribution. But if it is a discrete distribution, then what happens is for each return we will have a probability. In the case of continuous distribution, each return, there won't be an associated probability. There will be, all the returns will be there. That's why we call it continuous distribution. And so in that case, then we will simply add all of them and divide by n. That means each of them has the same probability, which is 1 over n. Here the probability is not 1 over n. So when the probability is 1 over n for each of them, then we can simply add them and divide by n. But since the probability is not equal, there is a different probability for each of these returns, we will take that particular probability and multiply it with the return, with the respective return. So let's look at an example. Here we are given a particular stock and we are given the returns of that stock in this column and the probability of that return. We can see that there are 1, 2, 3, 4, 5 possibilities are there, and all the probabilities will have to add up to 1. Okay. So as we said, we will multiply these two columns, and that is given here. For example, minus 15% into 10% gives us minus 0.015%, and so on. We can calculate for all the 5 cases, right? And we add them up. As I said earlier, we add all of these up and we get 0.090, or that is 9%, which is the expected return for this particular stock. This is under the case of discrete distribution. This is not compounding. Don't mix up. Discrete compounding, continuous compounding are something else. If there is any confusion, go back to my time value of money class and then take a look at what is meant by discrete compounding and what is meant by continuous compounding, right? There what we are saying is that the compounding interval, are they discrete or are they so small and tiny that it is almost for practical purposes continuous compounding. That's different. Here it is somewhat similar, but there is a distinction, and this is about the distribution itself. Is it a discrete distribution or is it a continuous distribution? And if it is a discrete distribution, then this is the method that we will follow. Okay. If it is a continuous distribution, then what happens? We will see that in a minute, but before that, let us see how to calculate the standard deviation, which, as I told you earlier, is the measure of risk, right? Risk means the variability, and a measure of variability, a statistical measure or a quantifiable measure. Quantifiable means statistical, and statistical measure of variability is variance, and the square root of variance is the standard deviation, right? From your statistics class, you will remember that the variance in the data or the variability in the data is captured through a metric called variance, and the square root of the variance is known as standard deviation, and that standard deviation is indeed the metric that we use for quantifying risk in finance. So how do we calculate the standard deviation? What we do is we take the rith return and subtract the mean return from that, and we square it, because sometimes it might be positive, sometimes it might be negative. So we square it, and then if you don't square it, then what will happen is that the positive and negative values will cancel out, and so we won't get a true measure of the variability. So to get a true measure of the variability, we will first square it and then we will take the square root. Okay, so that we will get back our original units. If you don't take the square root, you won't get the original units. So if you don't take the square root, that's also a metric, that's the variance. And if you take the square root, then you get standard deviation, which is back in the original units. So we take the return, the particular return, and subtract the average return, we square it, and then we multiply it by the probability, and we keep doing this for all the n items that we have, and we add up all these products and then take the square root of that. Okay, and that gives us our standard deviation. So standard deviation is a statistical measure of the variability of the distribution around its mean. What that means is, suppose we are having, let's see, suppose we are having a particular distribution. That means we are having many different returns like this. Okay, suppose this is time and this is return, and let's say this is our mean return. So some are positive, some are negative, some are as you can see that. So I have given some positive, some negative, and there should ideally be one more to balance it out. So this variability that is there around the mean, right, a measure of that variability around the mean is what is known as standard deviation. Okay, that's why what we are doing, we are taking this particular return, the ith return, and we are subtracting from it the r bar. That means we are finding out this one, Similarly, for the next one, we are finding this and so on. But since some are positive, since some are negative, if you simply add it up and try to get an average, you will get 0. You will get 0 by definition because the mean is in the middle. So some will be positive, some will be negative, and they will all cancel out. So therefore, we can't simply add it and find an average. We have to take the square. That's why we are taking the square. And then normally what we will do, if it is continuous distribution, we will divide by n. But since it is a discrete distribution, we have to multiply it with the probability. Just like we did for finding the mean, here also we have to multiply it with the probability, and that will give us the variance, and then we have to take the square root so that we will get the standard deviation. Let's look at an example. And again, note that this is for discrete distribution. For continuous distribution, I will show you the formula in just a minute. Okay, so here's the example, the same example we are continuing, for which we calculated the mean return as 9%. So what we are taking is, we are taking this return and we are subtracting this mean, right? And that will give us this value, and then we square that, and then we multiply it again with this probability. Okay, so in other words, what we have done, how did we get this 0.00576? What we did is, we took the negative 0.15, right, and then we subtract the 0.09 from this, and then we square it, and then we multiply it by the probability, that is 0.10. If you do that, then it will give you this value, which is 0.00576. Okay, 0.00576. Similarly, you will get these values. Then what do? We add all of these. So if you add all these values up, then you end up with this 0.01728. That is the variance. Okay, and so this is the variance. So what we have got here is the variance. So if you take the square root of the variance, then we will get the standard deviation, and so that is what we are doing. We are taking the square root of the variance. This is nothing but the formula which I have put again, but we are taking the square root of the variance, and so then we get the answer, which is plus or minus 0.1315. That means it is 13.15%. Whenever we take the square root, the answer will be plus or minus. That means what? That means that it is giving us an indication that, suppose this is our mean, right? This is our R bar. So when we are getting a plus or minus 13.5%, it means that the variation could be positive or the variation could be negative. That means the distribution is on both sides. That kind of a sense we are able to get when we take the square root, and that is the reason why we use the standard deviation, because it tells us that there is variability around the mean, and the variability could be either positive or it could be negative. Okay, although here in my slide we have not put the plus or minus sign explicitly, it is always there implicitly. I have mentioned it here explicitly. So the variability could be positive or negative. That is the implication here by taking the square root. So what have we done? Let us try to recap. This is for the discrete distribution. First we found the average. How did we find the average? All we did is we took the return and we multiplied it by the probability, and we did it for each and every item, and we added all of those products, right, all these products, and we got the expected return. Then to calculate the measure of risk, we took the return and we subtracted the mean, and then that is what we have here, and then we squared it, and then we multiplied with the probability, and that gives us our 0.0576. Similarly, we have done it for each of the 5 items, and then we have added it up to get 0.01728, which is the variance, and we know that the square root of the variance is the standard deviation, and that gives us our answer of 13.15%. Don't simply look at this video and think that you have understood everything. You may have, but it is best to practice, as I have mentioned before. So my request to you, my advice to you is to practice even this problem, right? Because the answer is there, the solution is there, and I have done it. So you should try it out yourself. Take a piece of paper, take a pen, and then try and do it out. Try and work it out and see if you are able to get the correct answer, right? Because that way you will be able to internalize the step-by-step process, so that you will be able to do it correctly next time you are faced with this problem, either on the exam or in real life. right? Now, so far we have focused on the discrete distribution. Discrete distribution means that for example, we looked at a discrete distribution just now, right? We had 15 minus 15%, 3%, 9%, 21% and 33%, and there was a certain probability associated with it. So that is what we have plotted here, right? The probability associated with 33% return, this is return along the x-axis, we have return, along the y-axis we have probability. This is a probability distribution. I just want to share one small anecdote here. As part of my responsibilities, I go and meet various business leaders in various banks and companies. And just last month, I was meeting with a senior leader at one of the top KPOs, banking sector KPOs. That is a top American bank which has a back office set up in India. And I also met with some European banks and so on. So one of them, and I think actually it was an European banker. He was not European, but he was an Indian, but it's for a European bank. It was one of the top European banks actually. And they have a KPO set up in Mumbai and in Pune. And I was talking to him, and he told me that when he interviews candidates, one of the things he presents them is a distribution like this. And then he tells them to write down what is along the x-axis and what is along the y-axis. And he says 90%, believe it or not, and he's not talking about some ordinary college or something like that. This is a top KPO and they interview candidates from the good schools, the best schools, maybe not necessarily the IITs alone, but good schools, right? And good schools meaning good colleges. And he says that 80%, I don't know if he said 90 or 80, but he said a very large number, more than 70-80% of the candidates are not able to label. They are not able to label the x and y axis. And that's a big shame, isn't it? I mean, so basically we should know the underlying concepts, we should know the basic concepts. Otherwise, walking into an interview like that with a top bank or a KPO of a bank does not make sense. Anyway, the point here is whatever we know, we should know thoroughly. This area of finance is an ocean. And within the confines of this particular course, I cannot impart, even I myself may not know entirely the ocean, because that's the nature of the ocean. Well, because of my experience and because of the studies that I have done through the CFA, FRM program and other MBA and so on, I have learned something, hopefully something fairly, fairly good chunk of what is out there in the practical, at least the practical element of it. But then it's an ocean, it's a vast ocean, and it's continuously being developed. New developments are happening. But what we know, we should know thoroughly so that our foundations at least should be solid. That is my goal in this course. And I want you to work with me so that if you face an interview like that, right? Suppose tomorrow, let's say you're working in Procter & Gamble, let's say you're working in Cadbury's, you're working in a technical role, you want to move to finance, and there's an internal job posting, and you apply for that, and then he asks, what is along the x-axis? What is along the y-axis? And if you stare blankly, or if you give some meaningless answers, then they will straight rule you out. So your dream of moving or transitioning to the finance department gets ruined. Or let's say you're sitting in a meeting with the senior leadership, and they ask, and you present a chart, and they ask what is along the y-axis, what is along the x-axis. If you are not able to answer, it's a huge problem, isn't it? So we should know the fundamentals thoroughly. Coming back, so that was just an aside, that's an anecdote. Just to, I think the point that I was trying to make is that our foundations should be strong. We should endeavor, you should put the effort. In my class, that is my expectation from each of my students, that when they go out of this course, they should have a reasonably strong foundation, okay, in finance. They should know all the basic elements. They may not know the super complex things. For example, if somebody says the Black-Scholes model, pricing of the Black-Scholes model, or something even more esoteric like exotic options or something like that, and if you're not able to answer that, I don't mind. I'm quite satisfied with that. I don't expect you to answer that. But if they ask you to calculate the standard deviation Or if they ask you, what is the measure of risk? And you stare back at them, that's a problem. You should be able to say that the variability in returns is what we are trying to quantify, and the measure of that variability is standard deviation, and here's how we can calculate the standard deviation. And you should be able to say that calculation varies depending on whether the underlying distribution is a discrete distribution or a continuous distribution, which is what we are talking about. So far we have covered the discrete distribution, the calculations relating to the discrete distribution. Now let us focus on the continuous distribution. Continuous distribution goes from minus infinity to plus infinity theoretically, and so that means what, this tail should go all the way to minus infinity. It may be that the probability is 0 after some point. After some point the probabilities might be 0, but it goes from minus infinity to plus infinity. Even with 0 probability is okay, or a minutely small probability, that is okay, but it stretches from minus infinity to plus infinity. That's one of the features of the continuous distribution. And again, similar to the discrete distribution, here we have probability, right? Here we have probability, and here we have the returns. Okay, so that is our returns, and this is our normal distribution. This curve should be familiar to you since you have done a statistics course. This bell-shaped curve we call as the normal distribution. Okay, so now we are going to focus on the continuous distribution and understand how to calculate the standard deviation in the context of a continuous distribution. As I mentioned, the bell-shaped curve is the normal distribution, and the area under the normal distribution is something that has certain properties, that is known as the normal arithmetic. The area under the normal curve, the total area is actually going to be 100%, right? So we have to include all the probabilities. So therefore this is the probability. So all probabilities are included. So the total probability will be 100%. Okay. There are some characteristics of this. Again, this is an aside. This is not something we are going to focus much in this course, but since we are talking about the normal distribution, I'm just going to mention this is something we will use a little later. We'll touch on it a little bit in the portfolio part, but not much. But this has wide-ranging applications in portfolio management and risk management, which we are talking about. But in a little bit more advanced course, within the confines of this course, which is a sort of like a baby step or an elementary course, we may not go much into it, but you should know this, and you probably know this from your statistics class, right? From your quantitative methods class. The normal distribution, if we go 1 sigma to the left and 1 sigma to the right, then the area under the curve is 68%. If you go 2 sigma to the left and 2 sigma to the right, the area is 95%. And if you go 3 sigma to the left and 3 sigma to the right, the area is 99.7%. Okay, or roughly it is 68% for 1 sigma plus minus, 2 sigma plus minus is 95%, plus minus 3 sigma is 99% roughly. This is something that is useful from a risk management context, from a portfolio management context, but within our curriculum we are not going to explore it further. If it is of interest to you, you can explore it, but right now we are going to move on. Just wanted to mention this since we are discussing about the normal distribution as part of the continuous distribution. So normal distribution is the most common continuous distribution, and indeed in finance we will assume for most of the work that we do that the returns follow a normal distribution. That's an assumption that we make, although we know in practice that is not true. But why do we do it? Because remember, it goes back to what I talked about earlier in terms of modeling. One of the fundamental principles of modeling is to keep it as simple as possible and no simpler. So therefore, we fall back on the normal distribution because it is a simple depiction of reality, and it is an acceptable depiction provided we recognize the limitations. If you fail to recognize the limitations, then we have problems. In fact, the 2008 economic crisis that happened, right, wherein Lehman Brothers simply vanished from the face of earth. Lehman Brothers was a top bank, investment bank, which simply disappeared. One of the drivers of that meltdown was because the analysts forgot about the limitations of the normal distribution. They began to assume that the stock returns follow the normal distribution. They don't, but we assume because it is simpler to model. So whenever we make some decisions based on metrics assuming normal distribution, we have to keep in mind the fact that actually the returns are not normal. We have only made an assumption, and therefore we may have to apply haircuts, or we may have to look at the data more carefully, right? This might only be a first step, and to make rigorous decisions we may actually have to do some additional work or apply some additional what we call as haircuts. That is, we have to, if suppose the answer comes out to be 12% risk, we may have to say, oh, because we assumed normal distribution, the risk seems to be 12%, but it might actually be 15%, something like that. So we have to do some sort of what if kind of analysis and things like that. But they forgot that, and they assumed that the answers that we were getting for a metric which is known as VAR, although we won't go into VAR in much depth, they assumed VAR is based on the normality assumption. That is, the distributions are following a normal distribution. VAR stands for value at risk, which is a very important metric in risk management. And VAR is based on the normal distribution. And since they knew that VAR is based on normal distribution, they assumed that the returns are normally distributed, which is not true. And they started believing the VAR number, which led to a failure and a collapse of Lehman Brothers and several other banks. Even Merrill Lynch got into a lot of trouble. Many other banks, insurance companies got into trouble, but the government bailed them out. But so what I'm saying is, we will simplify the real world with assumptions like this, but we should never forget that we made a simplifying assumption, and therefore the answers that we are getting should also reflect that simplifying assumption, and we have to take care of that. We have to say, okay, we got this answer, but that was only because we assumed something which is different from reality. Okay, and that sometimes people forget. Anyway, the point here is the normal distribution is important in finance, and we will use that extensively in finance. Within the confines of this course, we may not get into it much, but I wanted to give you some exposure as to what might happen if we forget the underlying assumptions of a model. Okay, so moving on. How do we calculate the expected return in the case of a continuous distribution? This is what we have done before, right? With the Tata Motors stock, that's what we have done. We assumed that it is a continuous distribution, and what did we do? We found the returns for those 59 observations over the 3 months, and then we simply add them up and divide by n. That is our arithmetic mean. That's our simple arithmetic mean, and that is indeed the expected return for the next period. So if you want to know what is the expected return next day or next month, because these are daily returns, it means the next day, what is the expected return next day, then what we will do, we will simply take the average. Okay, we will simply take the average of the historical data points. That's it, simple. And it's an arithmetic average. That's the simplest of the averages. We have already done that for Tata Motors. Let's look at one other example in a minute. But before we do that, let's see how to calculate the standard deviation. Remember, the standard deviation is a metric of risk, and we defined risk as the variability around the expectation. That is the unexpected variability. So we know this is our expected return. So what is the variability around that? How do we find out? The same thing we are doing, but instead of multiplying with the probabilities, what we are doing is we are taking the ith return, subtracting the expected value, squaring it, because otherwise the plus and minus will cancel out. So if you square it, then minus squared is also plus, plus squared is also plus. So therefore there is no cancellation. So then after squaring it, we add it up. But previously, remember, in discrete distribution, we would multiply with the probability also. Here the probabilities are assumed equal, and so therefore what we do, we divide by n. Okay, and then take the square root, and that will give us our standard deviation. So this is for the case of a continuous distribution. Previously what we did was for the case of the discrete distribution. Okay, let's look at an example. Suppose we have this data set, and although this looks like a discrete thing, for our purposes we are going to assume that it is a continuous distribution. That is, it represents the entire population. Okay, and we are having 10 returns. Normally we should have more data points, but for our, because if you are given 1000 data points, then the calculation becomes much more difficult, right, much more tedious, and so for our understanding we have limited it to 10 returns, right? And in the Excel example I had limited it to 60 returns, but ideally we should have more returns, then only it will be truly continuous distribution. But for our purposes, to understand the mechanics of the calculation, this is good enough. So we are given a set of 10 returns and we need to calculate the expected return and the standard deviation. So the expected return, so here I am showing the BA2 plus calculator, okay, how to do it, the steps using the calculator. I won't go into that here within the class, I won't go into that, but you can look it up, okay. You can do this calculation using Excel. Also I want you to do the calculation. I am not going to go into the calculation, so this is a homework for you. And if you have the BA2 plus calculator, the steps are given in the next few slides, which I am going to walk you through. Not the actual steps, but I'll walk you through the slides, and those who have the calculator can do it using the calculator. If you don't have the calculator, then do this problem using Excel or any other calculator that you have, any Calci that you have, you can use, okay. But if you have the Texas Instruments calculator, then in the next few slides I have given the guidance, okay, guidance is there. If some other calculator, then sorry, you will have to figure it out, maybe using the manual, or if it is a simple calculator, then you know the steps and you can do the subtraction, addition, subtraction, multiplication, addition, square root, everything you can do. So you should be able to get to the answer, okay. So I want you to work on this and before the live class, before the actual live class, you know, so you should try to do the calculation for this particular problem. We will go back to the Tata Motors example and I will show you the calculation there for Tata Motors in Excel. The same thing I want you to do. In Tata Motors we had 60 data points. Here I am giving only 10 data points. Whatever we are doing in Tata Motors, that's exactly what you need to do here, okay, with these 10 data points to come to the answer, to arrive at the answer. So here we are showing mechanically the step-by-step process for entering the data first, okay, and then once you have entered the entire 10 data points, then you can do the calculation through what is known as a statistics function in this calculator, and you will immediately get the expected return and you will get the standard deviation as part of the statistics, okay. So therefore this is very much quicker than actually calculating by hand, okay, and of course it will be a little bit slower compared to Excel. But nonetheless, on the exam, the calculator can be very helpful. So do practice. If you have the calculator or if you intend to buy the calculator, then these tips will be helpful for you, right? Similarly, I will provide other tips as well as we go along. Thank you very much and I will catch you in the next class. Bye for now.